Welcome to Techno Analyst. Today we will see how to configure Ospf. So why Ospf? Packets take a different routes when it's in a large and complex network. Some routes can be a longer while other are shorter. The fastest available routes are always the best. Hence we use Ospf mechanism. Open short path first. Ospf is a classless routing protocol. So it advertises a subnet mask along with the IP address, and that subnet mask is used as a wildcard mask. We will see later. And by default, Ospf is a use administrative distance, and its default administrative distance is 110. Why area is used in Ospf? In Ospf is a single autonomous system. AS can be divided into smaller groups called area. You can freeze the screen, you can stop the screen, and you can read all the information in more details. What is area 0 called in Ospf? It's a backbone area. This is a central area in your Ospf routing domain, which all area must connect to this. This is labeled area 0. When traffic need to pass from one area to another, it must be traversed through the backbone, means area 0. What is the process ID? Like example, you can see your router Ospf 1. You can mention over 2, 3, 4. This process ID is a number that is used to identify Ospf writing process on the router. Multiple Ospf process can be started on the same router. The number can be any value between 1 and 65,535. These are some Ospf characteristics which I feel you should aware about that. Ospf uses a link state routing protocol. It supports CIDR addressing model. Ospf only send update rather than the complete routing table. The simplest routing statistic is path cost. It supports authentication and send update every 10 seconds. To see that, you have to use show IP Ospf interface command, and updates are sent with the multicast address. For this also you can use the command show IP Ospf interface. Here, which I told you earlier, that wildcard mask. So wildcard mask is a reverse of subnet mask. Like Ospf is using wildcard mask. Suppose we are using 192.168.1.0 is the IP address. This is the subnet mask will be the 255.255.255.0. So it will reverse the subnet mask. What will be the 0.0.0.255? In this table, you can see that Ospf consider the wildcard mask, and the wildcard mask is like if the subnet mask value is 255, then wildcard mask will be the 0. You can see over there, and the subnet mask is 0. The wildcard mask value is 255. So please don't be confused while while giving this command, while you configuring the Ospf command. And the purpose of using Ospf, we can use Ospf in the classless routing to determine the fastest available routes for the packet. Especially these features help to accommodate a large network implementation. So now we will see in packet traces how we can configure Ospf. So here I will take 3 router. In this router I will connect 3 PC, 1, 2, 3. Again I will connect a switch, I will give router name like router A. This will be the router B, and this will be the router C. Okay, this router is not a install serial interface and all this, so we will install it. Don't worry about that. Click on zoom in, switch off, the router. Here you can see. Now you can switch on the router. Same you have to do over here. Click zoom in. Switch off the router. Install C interface. This is the middle one, right? So safer side I will install Ethernet also. That's not required actually. Because I'm using only one switch over here. Again in router C, we will install serial. Again in router C, we will install serial interface. Switch on the router. We'll give the router to the host name. So we will give the router to the host name. What we given. So we will give the router to the host name. What we will give in display name. So router underscore A. We'll use underscore A. Same we will use over here. Now what we will do, we will give IP address to all the interface. So what IP address we will use over, I will mention over here. So this will easy to understand. Like for router we will use 10 series 10.0.0.1. Here we will use 10.0.0.2. Here we will use 20 series 20.0.0.1. Here we will use 20.0.0.2. And for this interface router to switch, we will use 192.168.1.1. Here we will use, I think we will use class B router IP address 172.16.0.1. Here we will use again class C IP 192.168.28.1. PC IP address what we will use 192.168.1.2. Here we will use 172.16.0.2. Here we will use 192.168.28.2. So now we will connect all this interface. Use gigabyte 000 to gigabyte 1. From here to here we will use 002. This interface. Here we will use this interface. Again we will use this interface. Fast Ethernet. Now we will use connect serial cable. If we use serial DCE, then we don't need to configure clock rate. But GTE we have to configure because which router and we have to configure clock rate. So So that's the reason I will show you while configuring where how to set clock rate and how to check where and which router we should have to configure a clock rate. So this is how our connection is look like. Now we will set IP address to desktop IP address, desktop client, which is 192.168.1.2, and this is our default gateway 6.1.1. Same we will give over here. One 122.16.0.2 and the default gateway is 122.16.0.1. Here we will give IP address to 168.28. Default gateway we will apply later, not now. So now we will configure this IP address to the router Ethernet port, which port it is, it's gigabyte 0/0/0. So through command prompt I will not apply this, I will directly apply this because I want to show you the Ospf command. So to save all this stuff I can directly apply the IP address over here, 192.168.1.1. You can see over here that command. See, the moment I configure the command, the amber light come over and this turn into the green, so the connection is established. Same we can do over here. First we will check which interface is connected to the router, same gigabyte 0/0/0. So same we can apply IP address over here. That is the IP address 172.16.0.1. You can see over here all that command. Now what is the IP address? 192.168.28.1. Now all this connection is established. Okay, let's check this PC can, okay, successfully you can send packet over here. Yes, so we will wait. Okay, now we will check again. See, successfully it is transferred from here to here. Okay, so what we will do, so now we will run Ospf command. Before that we should check our router. This router A is a DTE router or DCE router to apply a clock rate. So what we will do, just go to the router, click command interface, click on and now type show controllers. The moment you click show controllers, you can see over here that this is a DTE router. So on DTE end you cannot mention a clock rate. you always mention a clock rate on DCE. So on this router you cannot mention a clock rate. So now we will check on router B. So in this router we will check, this is a, so in the real world scenario you cannot see which one is a DTE or DCE router, so you can see only through command. So here also now we will use a command which is show controller. Here you can see DCE and the clock rate is not 64,000, so we will mention 64,000 clock rate. What I will do for that, first I have to check the interface which is connected to the serial interface. So for that I will run the command show IP interface brief. Here I will check my serial connection which is connected or not. Okay, I will mention the IP address now. So that's why it's showing unassigned and down. Bloody hell. So to set a clock rate, what I will do, I will run a command. First I will go to the config mode. In config mode, I will run a command interface serial 0/1/0. Okay. In this interface, I will set a clock rate. Clock rate 64,000 and write command to save the building, save the command configuration, and now I will run the command show controllers. So you can see where this is DCE and the clock rate is set to 64,000 in this router. So now we will set IP address to all the routers. The same you can IP address like you can apply to the Ethernet. You will give like this one is 10.0.0.1. You can see over here the command. This command you have to use in while configuring this serial interface. Now on this end, this one is 10.0.0.2. And this one is 20.0.0.1. Same we will give over here 0.0.0.2. Now IP address is configured to all the router interface. Clock rate is also set. Now we will run Ospf command to all three routers. First of all, before I will run, I will show you some packet is traveling where to where. Like this PC can access to this router. Let's say this PC can access this router. Okay, this PC can access this router. Okay, all three are successfully send their data to the router. Now this PC can send data to over here. Failed. This PC can send data to over here. Failed. Now we will run ospf, and after that we will check that PC0 can send data to PC1, PC1 can send data to PC2. So for that, just first we will configure this router. In command line interface, enable the router, config mode, type router ospf1, type network, and first we have to use this area. Okay, so first we will configure this area 192.1.1 network 192.168.1.0 wildcard marks we have to use. Remember that wildcard marks we have to use. So reverse of subnet mask 0 dot 0 dot 0 dot 0 dot 255 area 0. Now again I will use command network. Now I will use this area 10.0.0.0 0.255.255.255 area 0. Now we will configure this area 20 dot network 20.0.0.0 space 0 dot 255.255.255 area 0. Here we will use one more command network. Now we will configure this area 172. So I will type over here like this 172.16.0.0 space 0.0.255.255 area 0. Now I will type exit. Again I will type exit. I will type right to save the setting. Now I will move towards to the router B. Before moving to the router B, what I will do, I will copy paste all the command on the packet tracer display page, so you will understand what command we use on router A. So this is the Ospf command we use on router A. Now on router B, we will run Ospf command. Config router Ospf1 network first we will add this interface, then we will add this interface. Then we will add this interface. Let's see. 172.16.0.0 is 0.255. One more 0. Dot 255.255 area 0 network 10.0.0.0 is 0.255.255.255 area 0. The moment I press enter, you can see it showing that the connection is going up. Serial interface connection is going up. We will check it later. Now again I will use again we can run same command for area 20. This is our area 20, this interface. So here we configure, here in B, router B, we configured this interface, we configure this interface, we configure this interface. We did not configure this interface. So before configuring this, we will check it is send this data to this interface. We will check this, and here also we will check this. We just configure this interface over here, not this interface. So I will end here and save the setting, and same I will copy paste the command for you. So in a router we configure only 3 interface. Here we will configure 1, 2, 3, 4 interface. Now we will configure over here on router C. Enable config. Now we will router OSPF 1. In the OSPF 1 just mention network 192.168.28.0 0.255 0.0.0.255 area 0. One more interface which I will mention over here, network 20.0.0.0 space 0.255.255.255 area 0. Enter. Enter. Right, to see the setting. Now I just wanted to tell you that I will just configure 2 interfaces over here. On itself the router. So right now router A, this is our router A, this is our router B, this is router C. So these are the command which we used over here. Now on this router, first of all on this router I will go and I will run the command show IP Ospf database. Let's check over here the database. Here you can see the process ID is 1, what we used, the area we used 0. Okay, these are the interface which we given over here. These are all the default gateway, you can say, or you can say the router Ethernet address at the router end we configured. So like this one, 198.168.1.1, which is this one, this IP address over here. It is showing over here 128.1, which is this interface IP address, and 16.0.1, which is this IP address. Even now I just wanted to show you that I will not configure this interface or this interface on the router C. So the command which I configured all this over here, which is not necessary, only these two command is sufficient itself on router A or router B. We will see in more details now. I will run one more command, show IP Ospf database router. Here you can see all the details of the Ospf router, all the router which is connected or interconnected to this router. So this is the network which is 1.0. This one our 1.0 which is connected. 16. This is our second router B. This is a serial interface which is connected. This is the router C which is showing over here. You can see link connected to a stub network, another router, a stub network. This is stub network. This is another router. Means right now we are on the router C. So the another router for it is router B. So it is showing that another router which is router B, nearby router. This is point to point, another router, means router A. You can. So now we will exchange packet from PC0 to PC1. It is successful. From PC1 to PC0, it is successful. From PC1 to this router C, it is successful. Wow. From PC0 to router C, PC0 to router C, successful. Now we will send PC2 to over here, router B. It's failed. Why? Because as I told you, there is no subnet type, default gateway. Sorry, I told you earlier we didn't mention a default gateway. So now 92.168.28.1 is a default gateway. Now we will check successful. Again successful. Successful. See, so I know I mentioned a lot of command here which is not necessary, but I just wanted to tell you in Ospf you don't require all these command to to increase your routing table on route. So to reduce your routing table we will use Ospf. So here we just need to configure those two commands. So we just need to just two interface, one itself which is connected to this and this. That's it. Remember one thing, this is the main purpose of Ospf, and the command we will use over here in Ospf, which is probably you should use while using Ospf, which is one we use show IP Ospf. One more command to see on the interconnected interface you should use show IP Ospf database. If you want to see our neighbor router, so you should use show IP Ospf database router. These three commands you can use over here. So this is how you can configure Ospf successfully. These are the commands you have to mention over in every router. Like in the router A, you have to mention only 192.168.1.1. This one, sorry, this first one command and second command. This bottom two command is not required. Same as router B, you just need a configure command which for this first and second and third. All three command is useful in router B because you have to mention this interface, you have to mention this interface, and you have to mention this interface. And here you can mention only this interface and this interface. That's it. So thank you for now. If you have any question, you can mention in comment box. I will reply to that. Thank you and please subscribe.